Random variable was a numerical variable by chance with the probability. So it is a numerical. So we discussed how can we get the mean, the expectation, because it was a numerical variable. Okay. So simply we just take the multiplication, then take the sum. It will be the mean. It will be the expectation. So we took the expectation here and here, right? Today we are going to take the standard deviation. So it is the variance and it is the standard deviation. It's cheap mathematical notations, right? So please erase everything. Except the mu. Who was the mu? Can you remember that? The mean, right? You know, before, here was the mu, who was the expectation, who was the average, the mean, right? So, at first we have to take the mean, the mu. It's not only here, in chapter 3, we took standard deviation. Do you remember that? 6 steps. Yeah, we took the exam. 6 steps. What we got, what did we get in step number 1? The means. Remember that? The mean. What we took in step number 2. What we did?
Difference.
We took the differences. Subtraction. See? Here? We are going to do. In the second step, we are going to take the difference. X minus mu. What we did in step number 3. Before.
Square.
We took the square. Yes. Here again. Step number 3, take the square. After, take the subtraction and take the square. What was the next? Yeah, we took the sum, but not now. I'm sorry, it's not now. Step 4,
Times a
we are
probability.
going to take multiplication, the probability, times the probability. Can you remember how we got the expectation, the mean? We take a value times the probability, and then we took sum. It was the expectation, it was the mean. So now we take the multiplication and then take the sum. Do you remember what we did after sum? It's actually, it was in step 5.
Divide by
We divided by
n minus
1. We don't have to do that.
No.
Just after take the sum, just to take the square root to get the standard deviation. Almost the same 6 steps again. We take the mean, difference, square. They are exactly same as what we did in chapter 3. But now, step 4, take multiplication with the probabilities, sum, Again, step 6 will be same as what we did in chapter 3. Take the square root to get the standard deviation. Right? It's almost the same 6 steps. Let's do it. So here's a sum. Please look at this example. I'm a bookstore owner. I assume each customer buy notebook, one book, or 2 books. And sometimes some customer buys more than 3 books, but ignore more than 3. Just focus on 0, 1, or 2. So I can make a probability table. Here is a book. 0, 1, 2. And here's the probabilities. 0.2, 0.4, and 0.4. So always when I sum up probabilities, it will be 100%. So now here is the number of books. Notebook 1, 2. Numbers. Here's the probabilities. So the number of books a customer will buy, it is a random variable. Now I can say the number of books a customer will buy, it is the random variable with the 3 values, 0, 1, or 2 with the probabilities. It's 0.2, 0.4, and 0.4. It is the random variable. In part A, what is the expected number? What is the mean? What is the expected number of books? Yeah? How can I do? Here. The value times the probability. The value times the probability. And then finally, take the sum. So the expectation will be the value times the probability, the value times the probability, and the value times the probability. And then take the sum. How much will be 0 times 0.2?
0.
Yeah. 1 times 0.2?
0
1
point.
times 0.4? Yeah.
Yeah, sorry. Yeah, 1 times 0.4 will be 0.4. Thank you. And 2 times 0.4, 0.8. Now 0.4 add 0.4 will be, 0.4 add 0.8 will be 1.2. For what? What is a unit? 1.2 what? Books, yes. What does it mean? 1.2 books. When I have a customer, I can expect I will sell 1.2 books to the customer. Does it make sense? Right? It's 1.2 books. Okay. How about the standard deviation? Already we took the mean expectation 1.2. It was step number 1. Now we have to make the table again. Here is the random variable, the number of books. 0, 1, 2. What do we have to do in the second step? Again, take the difference. 0 minus 1.2 is negative 1.2. 1 minus 1.2 will be negative 0.2. 2 minus 1.2 will be positive 0.8. Step number 3, take the square. How much will be negative 1.2 square? How much will be negative 1.2 square? 1.4 0.44. Thank you. How about negative 0.2 squared? Point 0.04. 0.8 squared. 0.64. Be careful, whenever we took the square, it will be all positive. All positive. Step 4. Be careful. Before taking sum, we have to multiply each probability. So 1.44 times 0.2. 0.04 times 0.4. 0.64 times 0.4. How much will be 1.44 times 0.2? The first one? 2.88. Next one? 0.04 times 0.4. 0.016. Next.
First one, right?
I don't think so. What is the correct one?
0.288, correct?
0.288. How about the last one? 0.25 and 6. What we have to do in step 5?
Add more.
Thank you. Do it. Please give me the sum. Say again? 0.56. One more. One more decimal, please. 0? Oh, okay. 0.560. Just a second. Who is this? Thank you. It is the variance. Yeah? After step 5, we took the variance in in chapter 3, right? Finally, take the square root of it. Square root of 0.560. How much? 0.73. 48.
No, 3. No, 7.
748. It is the standard deviation. A little bit different. 6 steps. Take the mean, 1.2. Second step, take the difference. Take the square. Now, times probability. Then take the sum. We don't have to divide it by n minus 1. Finally, take the square root. It will be the standard deviation. Any question? Can you do that? Good? Okay. Now we have a probability table. It's like this way. I want to go back to chapter 3. Okay? So if I had 10 customers, how many customers didn't buy anything? When I have 10 customers, how many customers do you think didn't buy anything? It's a 20%, 40%, 40%. So out of 10, 20%. I suggest to you, I have 10 customers, 20%. 2 of them do not buy anything, right? So let me put 0 and 0. How many customers buy 1 book?
40%.
4. So 1, 1, 1, 1. How many 2 books? 4. So 2, 2, 2, 2. So when I go back to chapter 3, we have 10 cases. How many books customer buy, right? Let's take the mean. Let's take the average. How did we get the mean?
Add them up. And
Add
divide.
up. And what? Divided by 10. You know, the formula was sum of xi's divided by n. Can you remember what was the formula in chapter 3 to get the mean? Sum of divided by 10. Average, the mean. Good? Right? Can I modify the summation like this? How do you think? You know, actually the multiplication, it is the repeated addition. 2 zeros, 4 ones, 4 twos. Right? So far so good? I want to split into 3 terms. How do you think? You know, the 10 is the common denominator. And sometimes we can merge them together like this way, or sometimes we can split. I cannot understand what I'm doing. Please let me know. Can you understand what I'm doing? No? I just take these 2, right? It's a 2 zeros, and 4 ones, and 4 twos, right? Yeah, yeah. One more time. How about this? 0 times 2 over 10, 1 times 4 over 10, 2 times 4 over 10. I just take, this is a ratio. Multiplication. How do you think? Are they same? The last step, how about this one? Point 2, point 4, point 4. Who is this? That is the expectation. In this way, we took what in chapter 3? The mean. Right? But in chapter 6, we took expectation, the mean, in that way, in this way. but they are same. You know, mathematics is not a magic. Math is a math. Right? Yeah. You know, in chapter 3, we had 10 cases. So in this way, we took the mean. But now it's already been summarized. How many percentages? 0. How many probabilities for 1? What is this for 2? Using the summarized probability table, in that way, we can take the mean expectation. But what we did in chapter 3, what we are doing, chapter 6, exactly same. Exactly same. Okay? So now I can add here. It is a chapter 6. Here is a chapter 3. We took the mean summation of xi over n. They are exactly same. They are exactly same. Right? Even when we took the standard deviation in chapter 3, it was the first step. What was the second step? Subtraction. Difference. Same. Step 3, we took square. Yes. Same. But in 4, we took sum in chapter 3, but we did in chapter 5. Can you remember what we did in chapter 5? Step 5?
Over n minus 1.
Say again?
Divided by
n minus 1. Yeah? We took the sum divided by n minus 1. But look at this. Can I rewrite sum times 1 over n minus 1? How do you think? Is this same as this? Right? You know, actually in chapter 3 we did times 1 over n minus 1. What we are doing? Times probability. You know, actually 1 over 1 minus 1, it was a kind of a probability. And then we are taking sum. Finally, take the square root to get the standard deviation. Please compare 2 chapters. Take the mean, take the standard deviations. Exactly same. Exactly same. The only difference is in chapter 3, we had the many cases. It's actually, it was a raw data. But now, summarized. Random variable. Numerical variable with the percentages, with the probability. Right? So we just modify. How can we get the mean from here? And we just modify the 6 steps to get the standard deviation. But please compare them, how much they are. Same. Almost the same. It's almost the same. Okay? So even though, yeah, in chapter 3, the title was the describing, displaying for numerical variable. Random variable was a numerical. Yeah, it's almost the same. It is almost the same topics. It's almost the same ways. So please try to understand how much they are same. Any question? In statistics, we have many random variables. It's already made, already given, right? So in chapter 6, I will introduce you some common random variables. The first one will be the Bernoulli trials. The first one will be the Bernoulli trials, and the second one will be the uniform model. And the main topic in chapter 6 is the binomial model and the Poisson model. I will introduce you 4 random variables. Bernoulli trials, it will be the first one. In chapter 7, I will introduce you another the common random variable is another distribution in chapter 7. Okay, so we are going to discuss a little bit about the Bernoulli trials and the others. Okay, the first one, the Bernoulli trials. Let me give an example. Toss 1 coin. When I toss 1 coin, how many outcomes? 2 outcomes, head or tail. In the Bernoulli trials, there are 2 outcomes, only 2 outcomes. Success or failure, tail or head. When I select one of you, male or female, only 2 outcomes. Okay? When I toss a coin, what will be the probability I will get head? 50%, right? When I pick it up, toss again, what will be the probability I will get head again? 50. Toss. 50. Toss. 50. 50. The probability of success, the probability of head, 50. It will be same. It is a fixed. That is the second one. That is the second conditional for the Bernoulli trials. The probability of success always same as the P. The probability of success. It is given. It is a fixed any single time. Okay? When I got head, pick it up, toss again. Do you expect what will be the next outcome? Already I got head. Nobody knows, right? It's a 50-50. Independent. Each trials, each toss, independent. That is the third condition for the Bernoulli trials. So when we have satisfy the 3 conditions, we can say it is the Bernoulli trials. The Bernoulli is the name. It's one of the names. Statisticians or mathematicians. You can Google. Who is he? Right? It's an old guy. It is very simple. It is a very simple random variable. Just a second. Random variable was a numerical. So now I can define a random variable x. This x is a random variable. It is the number of heads. I tossed just 1 time, 1 coin. So what is the possible values for the random variable? The number of heads.
25.
0 or 1. When is x equals 0? What does that mean? 0 head. We get
None.
tail.
Tail.
What does that mean? X equals 1? 1 head. We will get head. How much is the
Really
probability?
Yeah, I can't.
How much is the probability I will get tail?
50.
50%, 0.5. And how much will be the probability we'll get head?
50.
50.5.
You're being nice.
It is a random variable and it is a probability. Something wrong? So we can make the probability table and it is a random variable. It is a numerical, 0 and 1 with the probabilities each. Who is this? It is the Bernoulli trials. Only 2 outcomes, fixed probability of success, independent trials, Bernoulli trials, random variable.
So
It is the simplest one. Yes.
they're all 50-50 trials?
Yes.
Okay.
Yes. Why don't you take the expectation?
Yeah.
How could we get the expectation? Take the value times its probability. Take another one times the probability again. Right? So we
zero
had
times-
only 2 cases. 0 times probability. 1 times probability. And take the sum. How much will be?
0.5.
0.5.
Yeah.
0.5 head. When I toss 1 coin, I can expect 0.5 head. Does it make sense? It is a 50-50, right? When I toss 1 coin, yeah, why not? We can expect 0.5 head. Before, we expected 1.2 books. When I have a customer, we expected I will sell 1.2 books. Now, toss 1 coin, we can expect 0.5 head. Yes?
Your random variable starting at 0, is that a common mistake people do 1 and then 2?
No, I defined
Okay.
random variable was the number of heads.
Okay, alright.
No head, 1 head.
Okay,
Later, okay, let me introduce you the uniform distribution now.
Hmm.
Rolling a die, right? Now, the random variable x, now I can say the x is the number occurred, right? Now x is the numbers we got. How many numbers? 1, 2, 3, 4, 5, 6. How much is the probability I will get 1? 1 out of 6. How about 2? 1 over 6. 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 Now we can make a table. Yeah, why not? This way. It is the random variable outcome, and there is a probability. Okay, so the values, it quite depends on who was the random variable.
I was confused because I was thinking of the book. They just both happen to have the 0 in the first going out.
Yeah. It's a notebook, 1 book, 2 books, right? Yeah. So let me go back, let me finish the Bernoulli trials.
Mm.
So by the definition, Yeah, in this way, we can take the expectation, we can take the mean. 1.5 head. When I toss 1 point, we can expect 0.5 head. Why not take a standard deviation, right? In the first step, already we took the expectation. Now, here's the x, 0, 1. You know, actually, the Bernoulli trial is the simplest random variable. It's very simple. Be careful. It's too simple. Second step, we took the subtraction. X minus mu, 0 minus 0.5, 1 minus 0.5. It will be negative 0.5 and positive 0.5. Step number 3, we took square. What will be negative 0.5 square? Negative 0.5 square. Say again? 0.25. Thank you. Positive 0.25 and 0.25. What we have to do, step number 4, times probability. The probability were 0.5 and 0.5. So 0.25 times 0.5 and 0.25 times 0.5 again. How much will be 0.25 times 5? 0.125 and 0.125. Step 5, we have to take the sum. We have to take the sum. 2.125. It will be 0.25. Now it is the variance. We have to take the square root of it. How much will be square root of 0.25? Say again? 0.5, yes. 0.25 is the variance. 0.5 will be the standard deviation. Okay. Even though the Bernoulli trial, it was the simplest random variable, but it is a random variable. We can take the mean, we can take the standard deviation. Okay, good. Let me show you, just a second. In chapter 3, using numerical variable, we took mean, standard deviation, and also we made a histogram, right? Why don't you make a histogram? Let me open Excel. Yeah. Just a second. The probability was 0.5, and we have two scores. The number of heads, 0 and 1 head, right? So the 0.5 was the probability of success, probability of a head. And the other one, it was 1 minus the probability. That's 0.5, yes. To get the mean, we take the multiplication, x times probability, and x times the probability. Then take the sum. Yeah, 0.5. Can you remember? The mean was 0.5. Right? For the standard deviation, second step, we have to take the difference, x minus the mean, x minus the mean. Negative 0.5, positive 0.5. Step number 3, we have to take the square. Step number 4, times probability. I just do again what we did before, just before, and take the sum, who was the variance. The standard deviation, we have to take square root of the variance, 0.5. So mean was 0.5, standard deviation was 0.5. Let's make this histogram. Let me take the probabilities, insert. Oh, yeah, beautiful. See, it is not 1 and 2. It should be
0 and 1.
yeah, 0 and 1. Yes. 50, 50. No head, actually tail. One head is a head. 50, 50. How much was the mean? Mean was 0.5 between 0 and 1, right? And 6 steps, standard deviation was a 0.5 again. Yeah. Look at this. When I change the probability of success, it's not 50-50. I didn't click enter yet. When I change the probability to 0.8, what do you expect? What happened on the histogram?
They're not going to be the same.
Which one will be 0.8? 0 or 1? 1 will be 0.8. Then how much will be 0? 0.2, the other one, right? So we can expect here is a 0.8 and here will be 0.2, right? Then how much do you expect the mean? You know, actually the mean was 0 times 0.5 and 1 times 0.5.
0.8.
Now, thank you. Now it should be 0 times 0.2 and 1 times 0.8 will be
1.
0.8. And the standard deviation, yeah, 0.4, right? Now here's the 0.8 is 0.2. Does it make sense? Mean is actually mean was the center, right? It's a 0.8 because here's a more weight than this one. Mean moved to right, 0.8. Why don't you give me any probability less than 0.5?
3.
0.3?
Yeah.
How much will be the mean?
0.3.
0.3. Because here's a more weight. The mean was 0.5, but moved to left at 0.3. It's standard deviation, right? 6 steps. Yeah, it is 0.45 something. Okay. You know, actually, the random variable is a numerical variable, but summarized with the probabilities. It's nothing. It is nothing. And the second one is the uniform distribution, the uniform model. You know, in chapter 3, when we discussed the shape, one of the shape was the uniformly distributed. Do you remember that? Yeah. So when I think about the histogram, 1, 2, 3, 4, 5, 6. Height 1 over 6, 1 over 6, 1 over 6, 1 over 6, 1 over 6. Uniformly distributed. It is the uniform model. Yeah. So when I'm rolling a die, it is an example for the uniform model. Toss one coin, it is another example for the Bernoulli trials. The uniform model and the Bernoulli trial, they are the most simple random variables in statistics. Why don't you look at the second example? Have you ever gotten phone survey? Right? What did you do?
Hang on.
Yeah, just hang on. Most of the time, the machine can generate random phone numbers. So the last four digits, 0000 to 9999. How many random phone numbers from 0000 to 9999? 10,000, including 0000. 10,000 possible random phone numbers. For example, my phone number is 452 1234. What is the chance I will be selected? 1 out of 10,000. Yes. Yeah. If you have another phone number, 452 9200, 1 out of 10,000. Yes. Uniform model. Identically, we have exactly same probability, right? I just randomly select one of you here. 1, 2, 6, 10, 13, 17, 19, 24. Now, today I have 24 students. I just randomly select one of you. What is the probability you will be selected? 1 out of 24. 24. It's for you. 1 out of 24. 1 out of 24. 1 out of 24. Uniform model. Random number, it is a uniform model. It's actually. How many even numbers out of 10,000? 5,000 even numbers out of 10,000. How much will be? 50%. It is 50%. The even number, odd number, 50-50. How many phone numbers? The last 3 digits, 000. How many? Yeah, thank you. 0, 0, 0, 0, 1, 0, 0, 0, 2, 0, 0, 0, up to 9, 0, 0, 10. Out of 10,000 again. It is a 0.00. Is it 0.001 or 0001?
0.1. 0.1.
2 zeros? Try using calculator. I don't know. I'm not sure even. Yeah. It is a 0.001. 0.001. It is a 10 out of 10,000. So the Bernoulli trials and the uniform model is very simple. It is very simple. Actually, the main topic is the binomial model and the Poisson model in chapter 6. Please look at this one. This example, the tennis player. Do you like tennis? No? We have a player, right? The player makes a successful first serve. Do you know how can we call the success first serve? In tennis? Ace. Yes. He loves tennis. Ace. 67%. Right? Yeah. It is a 67%. The player tried 6 times. Now, okay, let me do here. Now let me take a random variable. It's a number of the number of successes out of 6. What does it mean? X equals 0. X was a random variable, which was the number of successes. X equals 0. What does it mean? Fail, fail, fail. How many times? 6 times all fails. Right? It's same as fail, 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 and fail. Does it make sense? Right? You know, X is a random variable. We need a probability. Why don't you take the probability? Probability X equals 0. Probability of fail, 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 fail. Right? Just a second. Between fails, should I say fail or fail or fail or fail? Or how about this? Fail and the second serve fail and fail and fail. How do you think? And or? And?
Maybe we go back to the 2 possible things of the or.
But focus on this one. And because player tried 6 times. 6 times, right? It's 1, 2, 3, 4, 5. I'm sorry, yeah.
I got it totally on that.
And.
Yeah.
And, right? We have to put and here. And here. Oh, just a second. A and B. In chapter 5, A and B. A or B. For the probability A or B, we apply the addition rules, right? What rule we applied for A and B? Thank you. We applied multiplication rule. Actually, we had 2 kinds of multiplication rule. Special one and the general one. How do you think? What should I apply? The special one or the general one?
Special.
The special one, why?
I could not tell you.
Just a second. When we apply the special one, they are
Independent.
independent.
You,
The serve, the 6 serves are independent or not?
yeah.
Yes. Apply special multiplication rule. What was the special multiplication rule for A and B? Probability of A times simply probability of B. Do you remember that? So now it will be same as